So got an example here of the polynomial. So we've got x cubed plus 5x squared minus 11x plus 3. Now, if we divide this polynomial by x minus 2, we get this value here, which is obviously our remainder. We've sort of done this previously. You know, px, our polynomial is going to equal our quotient times by our divisor, I'm just going to call that dx, plus our remainder, or it will equal px over dx equals our quotient, or plus our remainder. So we've got these two different forms here. Now, if we just put 2 in here, so you'll notice that x minus 2, if we put 2 in there, this thing would be 0, but if we put 2 into our polynomial, we actually get out our remainder. All right, so our remainder value we get in here. So this is pretty much what the remainder is. So in this one, when we have a polynomial, so we have px, so px is, let me zoom in a bit so it's just a bit nicer, is divided by x minus k. So this is just a rule. So k being a constant value, this gives us a factor. So when px is divided by x minus k until a constant remainder is obtained, remainder is obtained, then we get this pk equals r, which is our remainder. And what this is saying is just saying that if we put our k value in, one of our values of a factor, we'll get our remainder out here. So in this space here, we've actually got, for a proof of this, we would have, as we've stated before, we've got, well, px is going to equal our quotient times our divisor. Now our divisor is just going to be this x minus k factor plus our remainder. Now if we were to put k in there, sub k in for x, we would get q to the k times by k minus k. This thing here is going to equal 0, so we're going to plus the remainder. So we're going to get q to the k 0 plus r. This cancels out and we're left with just r. So that's sort of the proof of it. So an example of this will purely be use the remainder. So our question in this space is use the remainder theorem to find, I'm just going to write this as find the remainder of x to the power of 4. Now you'll notice I'm just using the textbook example, minus 3x cubed plus x minus 4 is divided by x plus 2. So using this theorem here, rather than actually doing the division myself, I can just go, I'm just going to go, well, p negative 2. Now I picked negative 2 here because my factor here is plus 2. So if x were to equal negative 2, that would give me a 0 in that factor. And so then I can just go, well, negative 2 to the power of 4 minus 3, negative 2 to the power of 3 plus negative 2 minus 4. All right, so we've got all those values there. Now, 2 to the power of 4 is 16. So 2 times 2 times 2 times 2. And the negatives will cancel out, so we're left with 16 there. 2 to the power of 3 is 8. Negative 8 times negative 3 is going to give me positive 24. And then we've got take 2, take 4. So negative 2 and negative 4 is negative 6. So let's just go, this is going to be 10 plus 24. The remainder is going to equal 34. So then we have, realistically, in this space here, we've got px divided by x plus 2 would have a quotient plus a remainder divided by x plus 2, or we could change the form of that. We would state this as when x to the power of 4 minus 3x cubed plus x minus 4 is divided by x plus 2, the remainder is 34. And we use the remainder theorem, so we'd put that in brackets. I will quickly write that out, but if you wanted to stop the video, you can. When x to the power of 4 minus 3x squared, cubed, plus, what else we got? X minus 4 is divided by x plus 2, the remainder is 34. Cool. Thank